Okay, we'll continue. Unfortunately, I know. Jerry, can you get the light, please? Thank you. Okay, let's continue. Okay.
Jerry! What? That's not mine.
I don't like you. What I do?
That's not my fault. Yeah, that's not all for my fault.
Are you okay?
It's not my fault.
Did he call you on his phone?
Yeah, I'm watching Council.
Right, continuing, Jerry. So, what we'd like to look at now, here is an example. Let's take something like two functions like this. F of x.
This is new?
Yeah, new. Inverse is the name of the lesson. And let's take this function, g of x equals x over 2. So notice if I calculate f of 10, what do I get? 20. And if I calculate g of 20, what do I get? 10. So if we think about it like this, if I start with a 10, the f takes me to 20. And if I start with 20, the g takes me back to 10. In other words, in this example, there's a relationship between f and g. That g undoes the work that f did.
No.
So in some ways, g is an opposite to f. It's like a type of opposite.
No.
So in this example, we say x over 2 is we call it the inverse function to the function 2x. If that makes sense, does it? The way we write that is as follows. If I say f of x is equal to 2x, then this is called the inverse, as an example. This is the inverse function of this. It is the function which will cancel. It will undo what the f did. Now it's kind of obvious for some examples what the inverse might be. For example, here is f, and here is f inverse. Let's do some examples together. The function 2x, we said the inverse of that is x divided by 2. What about the function x plus 1? What would be the inverse? X minus 1. Okay. What about, let's say, I don't know. Nearly. Let's say ex. No. Log x. Now here's an interesting one. 1 over x? No. No.
Log x.
No.
S square over.
No. No. No.
F
No.
power.
No. X power what?
1.
No.
Power 1 over 2.
No. No.
S power minus 1.
No.
S power 2. Oh.
Which is what?
S
No.
over minus S square.
No.
Yeah.
No.
Still 1 over x.
Correct. 1 over x. Because think about it. If I take the number 2 and I calculate f, I'll get 1 over 2. How do I go back to 2? I'd have to do 1 over 1 over 2. Yeah? Now, in a moment, I'll show you how to find this, the method. Okay?
Where is teacher?
Yeah, but these are just some examples. These some simple examples.
You should write all of them. You just remember.
No, that will not work. I'll show you how to do it. Okay?
So why I should write it?
To help your understanding.
just need to wait.
Shortly it will come.
Okay, I just let it wait.
That's fine. That is fine. Can I continue?
Yeah.
Yep. So, what you notice, or maybe not what you notice, but the relationship that F and F inverse, they cancel each other, can be written as a formula. F inverse is such that F composed with F inverse and F inverse composed with F together, they should always cancel to leave you with just X. So let's just check that with an example. We said earlier that Fx equals 2x. What's its inverse? X over 2. Okay, well let's check that. F composed F inverse. That's equal to F of x over 2, right? Which is equal to 2 times x over 2, which equals x. Yeah.
Oh.
Now this gives us new insight into the example I last gave you in the last class. Do you remember the one, what was the example I gave you last time? Fx equals minus x plus 2 over
2s plus 1.
Now this example is very interesting because the inverse of this function is itself. This is a little bit like the example with the 1 over x. 1 over x is its own inverse, just like this function is its own inverse. It will cancel itself. Yeah?
Here's how to use it.
I'm getting there. What we would like to do next is figure out how can we find the inverse of any function. So if I give you a function like e2x plus 9, how do we get the inverse of that? And there is a method for that. There's actually 2 methods. I'll show you both methods. Can I scroll down? Yeah. Right, so the first method. I'll use the example I just made up. Let's say something like 3e4x plus 1. What is the inverse of this? There's 2 ways to do that. Let me show you the first way. Are we ready to see this method now? And you might have seen this method in high school.
No.
Yeah? You might have, no?
No.
What you do is first you make this equal to y. This is like step 1.
Yeah. You should multiply. Oh.
Yeah, and then you want to find x. So we have this.
Yeah. Log.
And then log, yeah.
Yeah. Log e. Yeah.
And then
Good.
yeah. Minus 1 over
4.
That's equal to x. That's step 2 done.
Yeah.
And the last step.
Good.
Go. No, say it, Sean. What's the last step? Say it. Shh. What's the last step? You were going to say it. Tell me.
Say it.
Yes.
Go.
Be patient. No, don't look. Don't look. Okay, Christy, what's the last step?
Change x and y.
Yeah, you swap x and y.
Ah.
Yeah. So here you get log x over 3 minus 1 over 4. That is the inverse function. This is the function that will cancel the original function.
Why is that magical?
Huh?
Why is
Well, there is another way to do this, and maybe the other method will be clearer to you. Yeah, no, yes, we'll get to that in a moment. Domain and range is important here. So in this here, what's the domain? anything.
Anything.
But here the domain is not anything. It's not. The domain
More than.
is equal to the range of f, the previous one, because it's going backwards.
Yeah.
The domain of the inverse function is what the range of the original function was. So what is the range here?
Anything.
No,
No,
above 0.
Yeah.
Which, when you think about it, oh, that makes sense, because when I look here, I can only use anything above 0.
Draw star.
Yeah, but you can get that, from the start.
Yeah.
That the domain of this function is equal to the range of the first function.
Yeah.
Because if, remember what you're doing here, the f goes this way, and the f inverse goes backwards. So whatever the range is on f, that will be the domain on f inverse, usually.
Also, when we find a range, we just need to change. We just need to find inverse function or original function.
Yeah.
And then I think that into range. Of
Yes.
original.
Now, there is a condition to this, which I'll get to in a moment. Before that condition, I want to look at the other method. Can I do the second method? Yep. So the second method, let me use the same function. What was it? Fx equals 3e power.
That's 1.
Okay. Now, are you ready to see this method? What you do is you consider the process in getting the answer. Let me explain. Imagine you wanted to calculate this. We'll pick some number for x, like x is 10.
9.
What is the first? Don't annoy me, Lee.
Oh, I thought you want us to see.
I already did for you. 10. We pick some number for x, let's say 10, or whatever. 9 if you prefer. What is the first step in calculating the answer? What would you have to calculate first?
The power.
You would have to look at the power first. In particular, what part of the power? Yeah, but before you got the 41, what did you get first? Yeah, so in other words, the very first thing you did was to multiply the number by 4.
Oh,
Yeah, whatever, the 10 multiplied by 4. So the first thing was to multiply by 4. Now what would be the next thing? Well, you would you want to add 1. And then what would be the next thing? The e, the number. And then
3.
And then the last thing would be to times 3, which would be then 3e 4x plus 1. Okay, well that doesn't help us get the inverse, but it will in a moment, because what you can do is go backwards. Watch carefully. So I start with x. If I reverse the whole process, I would get x over 3, because the reverse of multiplying is dividing. What's the reverse of e? Log. So this becomes log x over 3. What's the reverse of plus 1?
Minus 1.
Wow.
What's the reverse of multiply 4?
Wow.
Really? That impressive? Same answer.
Wow. Unbelievable.
Is it really?
What is the
Yeah. Same answer.
No difference.
nothing?
So you have two ways to do this.
I mean, then can we
Both, yeah.
like this?
Yep.
But how
And
to
then
write
like
it?
pop-up.
Oh yeah, okay, so if you want to write it in the exam, okay, you might want to write it something like this. Yeah, yeah. No, for F, you could draw it like a table. You could say multiply 4, add 1, E, and multiply 3, right? So F inverse would be, what would it be? Starting from the bottom. Divide by 3, minus 1, log, and... oh, sorry, that's a...
log.
that was a...
Minus 1 over 4.
Oh, sorry. I did it. Hang on. Divide by 3,
Yeah.
log, minus 1, and divide by 4. So you could write, if you wrote that.
That's easy to write.
Yeah. Yeah.
Gosh.
No, it works for any function.
Same time.
Any function, yeah. Or any function. You can either solve for x, or if you write out the order of calculation, you simply reverse the order of calculation and each of the operations. So you have two methods. Now, is it always possible to find an inverse of a function? And the answer is no. It's not always possible to find the inverse of a function. I'll give you an example of a function that does not have an inverse, which might seem odd. You can say, why would a function not have an inverse? Well, here's an example of one. X does have an inverse. You know what the inverse of x is? X.
What?
The function f(x) equals x has an inverse. The inverse of it is x.
Oh, yeah.
Okay, so here is a function which doesn't have an inverse. Firstly, let me just tell you what the domain is. The domain is all real numbers. Let me just tell you what the range is. We'll say the range is all the positive numbers, including 0. This function, defined above, this does not have an inverse. It doesn't have an inverse. Why not? Yeah, but you think that, Sean?
Yeah.
Why does this not have an inverse? No. Why am I saying this doesn't have an inverse? You're thinking square root is the inverse. Kind of. Domain, yes, the domain is the problem. Now imagine this, if the inverse of x, you're saying it's square root x, right? Okay, well calculate this. What is f, let me see, f inverse f of minus 2. Why should it equal,
Your domain.
yeah, what's minus 2 squared? 4, and what's the square root of 4? 2. But we said earlier the inverse and the f should cancel, so it should have been minus 2. Now, as Bruce and other people spotted, it's the problem is caused by this. So what would be a solution? Yeah, limit to what? 0 to infinity. So sometimes in the exam they provide you with a function and they ask you, okay, have no inverse, what should the domain be so that it does have an inverse? But just so you know, what you need is this. For f to have an inverse, it must be what? What word from earlier lessons describes what we need here for f? What word from earlier lessons describes what we need for the... not this, it needs to be bijective.
What is bijective?
Bijective means one-to-one and onto. And one-to-one. Now the onto is not a big deal. It's very easy to make it onto. To make something onto, I just need to say, make the range this and nothing else. Then you say all the range is used. So onto is easy. Onto, easy. What's the hard part? The hard part is the one-to-one. If I use all real numbers, it's not one-to-one, it is many-to-one. So the hard part is making it one-to-one. Yeah, must make it one-to-one. That's the hard part. Let's have a look at an example. Yeah, but I'll just write it here, okay? Find the domain for fx equals x squared plus, I don't know, 4x plus 9 that will allow f inverse to exist. So right now this function has no inverse. Why not? Well, not one-to-one. So my job now is to make this one-to-one by making the domain the right size. But how might I do that? Any ideas? How might I make this one-to-one? How might I find the right domain? What could I do?
B squared minus
No. No. Any ideas? No ideas? No? Are you sure?
Oh, derivative.
Yeah, what about the derivative?
Linear.
No.
And from x is bigger than 0.
Yes, that would do. That would do. Why though?
Because if the graph
Mhm.
is like that,
Yes.
the derivative value looks like linear. You have no, because of the m.
Because the m, what about the m?
M must be bigger than.
Why?
I don't know.
Okay.
I think so.
No, you're right. The problem is this, okay? If we have a function like this, the reason it's not one-to-one, that it's a many-to-one, is because it fails the horizontal test.
Yeah.
Because it crosses twice. We need it to be a situation where it crosses once and once. Now, vertically, good news. Vertically, it always crosses once. What is the problem? The problem is horizontally it crosses twice. So how do I fix that? Well, easy. I can delete half the graph. If I delete this half and only keep this piece, then when I draw a horizontal line, how many times does it cross it? Once. Well, how do I delete this? I simply say use this domain from here to infinity, or maybe the other side. Well, yes, so we need to find this point. How do we find this point? So x equals... So you have two possible answers. Use either this or this. But don't use both. Just pick one of them. In the exam, they will just want you to give one example. So you could say you can use this, and now, huh? No. If they ask you to find a domain, unless they ask you for both, you should only need to give one. The words have to be careful. I miswrote. Sorry, Bruce. I should have said here, find a domain.
Just find a domain to possible. One of
Yeah. But you realize, see, the problem, Bruce, is there's actually many answers.
Yeah.
I could have said, I could have said this.
Yeah.
Or I could have said this. Right? Because if I'm out here at 100,
it's not wrong.
it's not wrong. Yeah.
No, pretty real.
No, it's not. It's not the maximum one. It's not the biggest one. Yeah. You get the same idea, but it gets a little bit harder for cubics. Because you realize with cubics you have a problem. Yeah. How many different domains can I make here? Quite a lot, actually. Quite a lot. Let's have a look at some pictures. Can I scroll down? Not yet. Yeah. Let me just check something real quick here. Yeah. Continue? No, still writing. Continue?
Yeah.
Okay, let's have a look here at a cubic example just to show you all the different domains you can make. And let's just draw the cubic like this. Okay, so I'm going to draw in blue possible answers. So you could have this answer here. You can go to here and to here. So you could use this and this. That's one answer, right? Another answer, you could do this. You could go from here to here and here down to here and here to here. This is another answer. Oops. Because if I draw a green line horizontally, how many times does it meet?
Once.
Oops, sorry. I should make one of these open. Open. Now this one here, I should make one of these open here. You know what? I'll just make them all open. It's easiest. Right.
Or you can.
You can close one of them. Yeah. Here, once. Here, once. Here, once. So this works. What else can we do? Let's see. We could do. Let's just. We could do this. Did I do this one? No, I didn't do this one. I'll make this open. Once, ish, once. So for a cubic, you actually have many choices here. Or you can even just do this. And that'll do it. You know, so the cubic you have many choices.
What is the answer?
They won't do cubic in the exam. In the exam, they only do quadratics. Yeah, or sometimes sine and cos. So if we think about sine and cos, the sine graph goes like this. So again, you have many answers because you could do something like this. But what do you think is the answer that it probably do for sine? Usually they kind of expect students to think of an answer like this. Yeah, minus pi over 2 to pi over 2 would be 1. Yeah? You get the idea? Yeah. What else could we have? I think this is kind of, let me just have a look at the worksheet. It's kind of it. Oh yeah. Something like, no, that's it. Log, yeah. So, in question 1, which of these is invertible? It means which one has an inverse. So, the first one, invertible or not? Yes, invertible. B? No. Well, unless you pick the right domain, but there's no inverse for B, unless you pick the domain. For this one, let's say the domain is all real numbers, okay?
Yeah.
So, B? No. C? Could be. D?
No.
Yeah, invertible. E?
Yeah.
No. F?
No.
Is invertible. G? It depends on the quadratic inside of it. Depends on the quadratic. Yeah. H?
No.
Well, no. Again, it depends on the quadratic on inside of it.
How does it depend on?
Well, if the minus value, if the minimum point is in the negative, then it means the quadratic never has a chance to be its two values because you can't put negative into it. I'll give you a very simple example. X squared, if I take something like this, x minus 1 and x plus 3. This one does have an inverse because you might say, oh, but it's a quadratic, so it has two values that are the same. Oh no, sorry, not this one here. X squared plus 2x. No, let me think. Plus 2x plus 1, or whatever. No. Plus 100. Plus 100. Okay. Here, where's the minimum? The minimum is at -1. Apologies. -100. There now. I'm trying to make my quadratic like this. I'm trying to make it so that it looks like this. But these values I never get. In fact, I can never get any of these values because I need this part to be positive. So if I square root this part here, that's fine. Because I'll never square root a number that could make the same value. Now this one here is a problem. X squared plus 1. Because if I use 3 or -3, what do I get inside here? I get root 10 and root 10. The problem is I'm allowed to use this.
So you can use -3.
I can use -3, but this one is not no inverse, not invertible, because I can use a value which makes the same answer again. So it depends on what's happening with the quadratic. Okay. In number 2, what do I need in number 2? Yeah, in number 2, I want you to find the domain that will make this have an inverse. In number 3, I want you to find the inverse function using either method. You have 2 methods for number 3. Number 4, I just want the inverse of this function, and then number 5. Oh yeah, number 5, I want the plot of the inverse, which is a little bit hard. I want you to find the inverse and plot it.
And plot it.
And plot it.
Into a graph.
Yes.
A graph of the inverse.
The graph of the inverse. What is the inverse of sine?
Of cosine.
Sine inverse. Tangent.
Funny, the inverse of sine is sine inverse. The inverse of cos?
Cos inverse.
And of tan?
Of course, sine inverse. Tan inverse.
Tan inverse. You think it's tan inverse, but actually, no, it is tan inverse. Yeah. So, sine, it's sine inverse, cos inverse, tan inverse. So the -1 is not representing a 1 over. It's just representing inverse. Yeah. In chemistry, you have this function, log base 10 of x. You use it for PHP. What is the inverse of log base 10? pH level. You use log base 10 when you're calculating pH level. You haven't done this? Anyway, it doesn't matter.
10 power.
Yeah, what's the inverse of log base 10?
10 power x.
Yeah.
10 power x. But some people actually call this anti-log of x, base 10. This, anti-log, as like a log inverse nearly. Do you understand? Yeah? I want you to try these for a few minutes.
Can we skip 1 and 2?
Can we skip 1 and 2? I made these questions, so what do you think I'm going to say?
I mean, we'll question 1 and 2 together.
Question 2 I've seen in the exam, and question 1, it would be like maybe a 1-mark question in the exam. They would want you, again, it might be something like they give you 4 functions and you have to say which one has the inverse or which one does not have the inverse. Yeah. Try these, please. Jerry, can you put the light on?